Uh, Thanks for having me. My name is Fabian, and I'm going to present something about Instana. And obviously, Instana loves cloud-native Java. Today, I'm here, but I'm not alone. I brought with me my trusty friend Stan. He is our mascot and very helpful assistant. Quick words about me. I co-founded Instana like 3 years ago. I am one of the core architects and developers of Instana, and I have done performance consulting before. I have seen large and small IT infrastructures, and I took some learnings from that. You can reach me on Twitter if you like. If you don't need to. So I was wondering when I saw the previous two talks, what's actually cloud native? So I know what Java is. But what's cloud native? And actually, there are a couple of definitions out there. This is my definition. I just came up 10 minutes ago. What I saw from the first talk is, well, you can have something running on Windows, running in Linux, running in Windows, running in Mac. I don't know. So you can just take things and put them together. And the good way to do this right now is microservices. So you need to make things you can put together, which have APIs and which are able to find each other and can talk to each other. Now that we have made those microservices, that little overused buzzword, we put them into containers, which is our new deployment artifact. And now that we have many containers, we have the problem, we need to figure out where to put those containers, on what worker nodes, on what physical hardware it needs to run. How to make sure everything is up and running, the right amount of servers is up and running. So we have orchestrators for that. And I was thinking about building fancy animations because actually we don't really have any container technology. We just have Docker now. Everything else is kind of dying off like rocket. And when we talk about orchestrators, well, I'm pretty sure that Kubernetes is the one survivor. I'm not so sure about Mesos. I heard Mesos is also migrating to Kubernetes. Google and Amazon have Kubernetes support, even when they still have their side projects. So we are using Docker and Kubernetes de facto. But if we want, we can use something else. And I think that's also a nice aspect of this whole cloud native movement is use what's best for your problem. And in that term, it might not be Java. And in fact, I've seen in the demos before quite a few components which are not Java, which we just use to put it together, like traffic, or like HTTPD, or like Nginx as web front ends, load balancer type of things, or like Consul for service discovery, or well, Zookeeper is Java, but you can also use etcd, which is not Java, which does service discovery, helps you to make sure your components get the configuration correct. So you can use whatever you want. And this is, of course, a problem when you can use whatever you want. There's so much choice. What do you use? So there is this new, or not so new, Cloud Native Computing Foundation, CNCF, which tries to organize this mess a little. But I would argue that in the end, it's still a mess. It's a chaos. And what better could represent the chaos that we have now in our deployments by the ones who invented that chaos. Netflix came up with this, said, OK, we are very early adopters of microservices. We have thousands of containers. What happens if they break? So they introduced that concept of their Simian Army, which destroys everything all the time, that forces developers to build in resilience. But it shows that there is really a lot out there, a lot more than just your Java application. And we have built a solution that is covering this. It can have a look at Java applications. It can provide very deep insight into it. But it can also provide Nginx and other things. And because slides are boring, I will just take this opportunity to give you a little demo and explain a few things we might be offering for you or some colleagues of yours. So here I have our new release we rolled out yesterday on our demo environment. And what you can see here is one of the predefined views. Maybe do a little more full screeny thing. It's a web application that renders interesting things. In this case, we are looking at a physical deployment because, well, in the end, everything runs on servers. And today, most of it runs on Amazon servers. So for example, this is an Amazon server running in US East. That's great. And it runs a lot of stuff. It runs Java applications, and it runs Nginx. No, it runs HA proxy, this thing, and it runs a Zookeeper, and it runs JVMs, and this doesn't run Spring Boot apps. Maybe I could search for a server running Spring Boot apps. Okay, here are our Spring Boot apps. There is a shop service. Of course, every good demo needs to use an e-commerce example because e-commerce is what runs the internet. And this is a Spring Boot app we are monitoring here. It uses the Spring Actuator endpoints to provide some information. You might say, oh, that's not a lot of information on a Java application. I know my Java apps. There should be more, and there is actually more. So you might be interested in looking at the JVM metrics. Maybe this has a memory problem you want to investigate. Maybe this data is too old for you to work with, and you really want to have really up-to-date data. So what Instana does is we capture data every second so that you don't need to wait like 5 minutes until your monitoring tool has understood what's the current state. This looks quite fine. You can drill down into the space usage of the heap, whatever you want to do, we have it. Of course, this is a demo, so this is a little boring. But we also know that this runs in Docker container. So this is deployed in a Docker container, and automatically we are able to monitor it. And automatic is a quite important thing because changes are happening. You might be redeploying this app a few times a day because you have new releases or you want to do scale out and you want to ensure everything is running fine. So there is a loss of 2 seconds of data, but that's not so bad. There's new data coming in all the time. Yeah, so we have this, what people would call traditional infrastructure monitoring, but this is not traditional infrastructure. This is modern infrastructure. We have here, you might have seen that there is like a Kubernetes demo. This is actually run by Mesosphere Marathon. So if we want to look at the deployment config of Marathon, we can see how much CPU resources are allocated on the lower left-hand side of the screen. We can have a look at the labels, which is a little boring here because, again, it's a demo thing. We can also change the grouping. So right now we have a traditional infrastructure grouping, which is not what we want in cloud days. So maybe let's look at the Marathon application IDs that is tagged to the containers. So we can clearly see our replication is currently 1. We only have 1 of those things. That might not be a good thing. Maybe look at the Docker images. It gets a little messy here, but for example, we see that the Marathon load balancer, which is an HA proxy instance, is deployed 3 times, and we might want to look into the HA proxy data that's coming out of here. Not very exciting, right? So this is a more infrastructure-focused thing, which is what many tools can deliver. And for example, Spring Boot admin allows you a little more than what we have in regards to manipulating the running app. We are more in collecting information from all the applications. And actually, all those applications we're having here, there is like a demo script running behind which generates some traffic. we see automatically all the interaction between those applications. Now, when I say automatically, this scares some people. You might want to have control. And actually, there is an interesting discussion going on whether you as developers should take care of making sure that monitoring works, right? So use a standardized log format. And now the new trend comes up with you need to provide tracing. You can do that. You can use, for example, open tracing to instrument your application so that you're generating spans. When you use open tracing, you know what this is. I will show it later to you. And we will pick them up and use them for our data presentation. But I'd argue that there is a lot of code out there that you don't want to touch anymore to put instrumentation in, or you don't really know how it works. Maybe it's a fancy akka application in Scala where you don't really know when the message is handled and when the handling is done because it's run on a different thread. Maybe it's even run on a different JVM, and you don't really have control over that and would need to implement a lot of things to manually do that. We do it automatically for you. You see, most of the traffic is coming in here from the middle. We have an alternate display, which might be nicer, which is more like a visceral flow style, where you see everything is coming from the left-hand side. And there is a, actually, if I spend 2 more minutes, then our scripted problem might pop up. I see first things manifesting already. But maybe let's look at this one thing here. Again, we can I don't really like this new MacBook keyboard. This is just a little annoying. I type too hard. That's a problem. So let's only look at the shop transaction. We see shop does outbound calls to another web application called product search. It also talks to RabbitMQ and does direct calls to products. Sometimes it seems to call other HTTP endpoints, which are right now not receiving traffic. And we can monitor the traffic that goes through this application. Again, you can have provided manual instrumentation or use our automatic one, and we will tell you latency spikes like this one. There was latency spike, but that wasn't too bad. Maybe we go back a little further. You might see that the scripted error I just mentioned before has appeared in the past. So maybe we go back into the past by using, whoops, this thingy which currently is wiggling here. Let's go back in the past in our timeline to see the problem in action when it was still happening. So maybe let's go here. You see there is a problem on the shop service. It receives calls and 100% of those calls fail. What's going on here? We might want to check our application map again. So you see it's also red. Maybe we look at the total map. I see that shop is calling product search, and product search is yellow. It only has a minor problem, but that it does an outbound call to an Elasticsearch cluster, which has a major problem. So we identified already a big part of the problem, but as developers, we maybe want to get better data. We don't trust this robot to find the problems. So let's look at the recordings that have happened. And this is our Traceview. When you are familiar with, for example, what Zipkin does, they have a similar Traceview, or other commercial tools offer this. We are tracing every request that goes through the application, either automatically or when you want to do it manually. And we see this is a distributed application. There are multiple services involved. Still a little simple, but it works even when you have 20 hops. So this first call was a synchronous web call. It was doing an outbound call here. We captured all the parameters that are attached to it. And then we see that in this JVM, we have all the stack traces that were happening. It was doing Elasticsearch calls, which then failed. And this Elasticsearch call, we have the data to that, and that one failed, and of course this error bubbled up and produced an overall error. So we have all this data, we give it to you, you can export it, there are APIs, you can alert on this automatically. We can alert only on those incidents that we detect, because this was affecting the service. But you might have an Elasticsearch outage that could produce problems that is not affecting your users, so you don't need to alert on that. You can decide whether you want to do it and with what criticality you want to alert on this. And there are many other features in this product. I don't want to give you such advertising now, so if you have interest in that, we can talk about it. But what I want to say is when you're doing such a polyglot cloud-native deployment, you are having so many components you cannot manually monitor them anymore. And trying to manually set up monitoring for hundreds and thousands of infrastructure components is really painful. You might not even be knowing what it is. So you just use this Docker image and it brings now Envoy. Nobody knows what Envoy is, but the one developer who just left the company used it as a service mesh to integrate his new Node.js application, and you still want to operate it. You need something that helps you to understand what's going on automatically, continuously, and with as least manual effort as possible. And we have built this. Also, interestingly, this is all built on Java. So our whole Instana backend is also Java. It's not so microservices. There is a lot of data going through. I have a whole talk on this if you're interested. You can find it on my speaker deck account. If you're interested in like backend stream processing architectures with Cassandra and Kafka, have a look at that one.
Are there more plans to support root cause analysis in the tool?
There is actually like a root cause analysis feature in here. So the problem we have seen, we have automatically detected where it was propagating, in which order things were happening. The data model behind that has everything connected, so it knows this service is talking to that service, it's talking to Elasticsearch when Elasticsearch failed, and the calling service fails, well, this is very likely related. Of course, there could be always other things happening, and it just might be coincidental. But there is a machine learning algorithm behind that is even predicting that this is going to happen, because it sees like error rates growing or CPU usage growing. And there is some automatic root cause analysis like this happening. And what we will offer soon is basically an explore mode where you can look at, for example, please tell me all the Elasticsearch queries that failed. Maybe there is a common pattern, or is there a common root? Is the failing Elasticsearch call always coming from that server? That will give you some of the insights. The data is all there. You can access it manually already, and we are building more and more features based on customer requests like this. So there's a lot of stuff coming.
This is product software as a service only, or also on-premise?
So we prefer software as a service, because then we can help you better get the most out of it. If you have it in your own data center, then we need to send you one of our pre-sales guys to annoy you. I hope this is not recorded. Thank you. So, of course, you can install it also in your data center and then have it all under your control. We are also working on the SOX compliance, so if you have questions on that, we can answer it. So, but if you want to have it on premise, this is also possible. It's a fully maintained stack by us. You just install an RPM, and that downloads a few components from us, and then you're ready to go on your own. Yeah, but I would recommend the fully managed thing. But of course, I understand that sometimes there are policies and things that cannot be changed.
How does it do that, or not in detail, but in general?
Well, first of all, thank you for confirming that this is not so easy. This is a very
extremely difficult.
this is a very often overlooked aspect when you want to do it manually with stuff like Zipkin or open tracing. So let's talk a little bit about how you would generate this first blue box. This is very simple. This is a Spring Boot application. There's a Spring dispatcher servlet. You could write your own filter, and I think there are some open tracing contrib filters out there that are very easy. It's a synchronous HTTP call. Do service method starts, then start timing and capture all the parameter. Do service method ends, end this thing. And record the time, and maybe if this had an error, set an error flag. And then you know this, and this is what's called span in distributed tracing, Dapper style tracers. Now what happens if this is an asynchronous request? When is it asynchronously ended? There are various ways to do it. For example, in Spring this Drax web service, DraxRS web services, there are many ways to do it. It ends when the request is fully consumed and the response is written, but this might not be the same thread. It might, in this case, it must be the same JVM. In Akka, it can be replicated to another JVM even. We do it automatically by knowing those implementation details. We know that there must be a request object handed to another thread. And we can recognize that request object automatically because we attach this to a tracking map, and then we check, oh, this is a request handler again, and this looks at the map and then sees, oh yeah, I saw it's connected to this incoming request. But you, when you write your code, you don't have access to that. This is hidden in the framework you're using. You might not have access to the correct Akka message that is representing where this is transported. So we doing bytecode instrumentation to modify those frameworks we're supporting to trace this through where the asynchronicity is happening. And there, you have a really hard time to do it manually. I know that in the new Spring reactor, there is a asynchronous context being built in, which you could use for this purpose. But there are many frameworks where you don't have access to it, and it's very tedious and error-prone. For example, in a Zipkin, you need to make sure that you nest everything correctly, that you know who was the caller. So it's a lot of work, and this little advertising, use Instana, it just automatically works because we have done this work for you. So, yeah, the question.
If I wanted to have this instrumentation feature, must I instrument the code? Or
no, you.
Do you have an agent?
So I didn't talk about the install. So of course, cloud native. So what you do is you deploy the Instana agent as a Docker container, as a daemon set, for example. So it's running once per worker node, and everything else is done automatically. But you just deploy it as a container as you would deploy any other sidecar containers in your application. Thank you.